Alright guys, I'm making an answer key here live and on tape. I'm going to do this in real time, so if I make a mistake, you get to watch. Okay, so this is our answer key. We are solving this, and a solution is usually an intersection point, but when it's an inequality, you get a region, so you got to just zero in on the fact that these are inequalities. This is already an mx plus b form, so the intercept here is at 5, so I go up 1, 2, 3, 4, 5, and then the slope is down 3 over 1. It's negative 3 over an invisible 1, so it's going to be like that. There's no line underneath that, so this is going to be dotted. Put arrowheads on the end of that, and it's a region, and I can find that region either by plugging in 0, 0, in which case 0 is less than 5, so I should shade this way, or I know that y is less than is really shading down, but at any rate it's on this half of that boundary line. This one I'm going to transform this by subtracting 4x from both sides into y equals mx plus b form, so minus 2y then is less than negative 4x plus 8. When I divide everything by a negative 2, I'm going to get y by itself in positive, but I also have to remember to switch the signs. So I get y is greater than, and then negative 4 divided by negative 2 is a positive 2x minus 4. So here is 1, 2, 3, 4, my intercept, and I go up 2 over 1, and again it's a dotted line, and I shade then above, so I'm just going to very clearly fill in this region here. Okay, so that is a graphical representation of the solution. I do not need to find that individual point of intersection, but I should toss on there 5 and 5 just to give it some scale. Always put some numbers on there. Alright, so substitution method. I'm going to solve this now so that I get y or x by itself. It's probably easiest to transform this to get y by itself. When I do that, I get y plus 4x equals negative 1 when I divide everything by 2. Or I could have moved the x over first. That might have made more sense. But y equals then negative 4x minus 1. So that's what y is equal to. So I put that in place of y right there. And I write then 4x minus 3 times negative 4x minus 1 equals 19. Just be careful making the substitution. Then 4x plus 12x, and a negative 3 times the negative 4 gives me the plus, but a negative 3 times the negative 1 also gives me a plus. 3 equals 19. That's 16, and when I take away 3, that's very convenient. I will get then 16x equals 16, so x equals 1. I plug in 1 into any equation that I want, and I'm going to get 4, let's see, right here is the easier one. Negative 4 minus 1 is minus 5, so y then equals negative 5. Okay, try to write the answer as an ordered pair, 1 comma 5. That's the single best way. Doesn't hurt to check. 4 minus, that's a negative 5. You've got to be careful. 4 minus a minus 15 is a positive 19, so that checks. Okay, now I'm going to solve this last one, or the next one rather, by the elimination method. That's called Gaussian elimination. You might want to know a little bit of history trivia there. To do this, I want these to cancel somehow vertically. Looking at this, I could get the x's to cancel, but it's much easier to get the y's to cancel because all I have to do is multiply this by 3, and I'll get a positive 9 canceling with my minus 9. So I'm going to recopy 5x plus 9y equals negative 8, and I'm going to multiply this by 3, so I get 12x minus 9y equals, multiplying by 3 gives me a negative 42. Sorry, it gives me positive 42. I'm just multiplying by a positive 3. That's really the only thing you have to fear in this, is just making a little mistake like that. These will cancel, and I get 17x equals, in this case, 34. So that's pretty convenient because it looks to me like x is going to be equal to 2. And I will sub that in to either equation, but that's a pretty close one there. So I'll say 4 times 2 is 8, minus 3y equals 14. Negative 3y then is equal to 6, and y then is equal to negative 2. And again, I'll write that answer as an ordered pair, 2, comma, negative 2. It doesn't hurt to plug it in and see if I have 10 and I take away 18, I get a negative 8. All right, on to matrix math. It says perform the matrix math given the matrices below. If it's not possible, just write not defined. Actually, better to say why. Say something like dimension mismatch. Maybe I'll fix that by the time of the test. All right, A plus B. When you're adding matrices, just be careful to add corresponding parts. I'm going to write it here. It's going to be a little bit small. I hope you can see it. But 1 plus a negative 2 is negative 1. 3 plus 4 is 7. Negative 2 plus 6 is 4. And 7 plus 0 is 7. Okay? A times B, that's matrix multiplication. I'm going to leave these since it's in the right order, and I'm going to take this top row and flip it, 1 and 3, smack it, multiply it, and add it, and that's going to give me this matrix, which will also be a 2 by 2. It never hurts to check the dimensions, 2 by 2 and 2 by 2. Make sure the inner ones match up, and the outer ones will determine the final product. So it's going to be a 2 by 2 again. When I flip 1 and 3 and multiply, I get negative 2, and 18 adds up to 16. When I multiply this times the next column, I get 4 and 0 adds up to 4. Then when I take the bottom row, negative 2 and 7, negative 2 and negative 2 is 4, and 42 is 46, and then negative 2 times 4 is negative 8, and 0 gives me negative 8. So that's that solution. 3C, I just take this and multiply it every single element by 3, and I get 24, 0, 15, and negative 3, 3, and 33. Okay, and then finally A plus C, no can do, dimension mismatch. All right, so that's page 1.